A power station delivers 7,000 kilowatt of power over long distance to a region using a 110 kilovolt power line. If the wires used in the transmission of power have a total resistance of 80 ohms, how much power is wasted to the wires in the delivery process? If I say power equals to V squared over R, and the voltage is 110,000, and then I square this and then divide it by R, 80, I would get about 1.5 times 10 to the 8th watts. Would this make sense? The power station is trying to deliver 7 times 10 to the 6th watts, and the 1.5 times 10 to the 8th watts is being wasted by the wires. So this does not make sense. This is wrong. The reason why this is wrong is because we use the R for the wires, but the wire does not get all of the voltage because the circuit actually looks like this. The power station provides 110,000 volts. This is kind of like the battery. And the wire has resistance, that's 80 ohms. I'm just concentrating all the resistance in the wires right over here, 80 ohms. And these wires, they're connected to the load. The load would be the electric appliances or machines that use electricity. So effectively, the 80 ohm wires and the load, they are connected in series, which means that they have to share this total voltage. The wires do not get all of the 110,000 volts. That's why this is wrong over here. In fact, the wires only get a very small fraction of the total voltage. So in this problem, we need to tell apart whether we're talking about the wires or the whole circuit. For example, the 7,000 kilowatts is the total power in the circuit. 7,000 kilowatts, that's the power in the total circuit. The voltage is also the voltage for the total circuit. So this is the voltage for the total circuit, which is 110,000 volts. And then the 80 ohms. The 80 ohms is the resistance of the wires only, not the total resistance in the circuit. So this is 80 ohms. And what we want to find is the power being wasted to the wires. That means that we want to find the power consumed by the wires only, not the whole circuit. We have 3 power equations. Power equals to IV equals to I squared R equals to V squared over R. So in order for us to find the power consumed by the wires, we need to know 2 things about the wires. We already know the resistance. That means we'll either have to find the current or the voltage for the wires. And in this case, because the wires and the load, they are in series, that means everybody gets the same current. So it'll be easier for us to find the current in the wires, just because that also equals to the current in the total circuit. And we can certainly find the current in the total circuit because for the total circuit, we know 2 things. So we can use P equals to IV. And this has to be the current in the total circuit, the voltage in the total circuit. So the total power is 7,000 kilo, and that equals to the current times the voltage, 110 kilo. So this will give us a current that is 63.64 amps. And this is the current in the total circuit. It is also the current in the wires. So now for the wires, we have the current and the resistance. So it will be convenient for us to use I squared R. And that would be the current 63.64 squared times the resistance of the wire, 80. And this will give us about 324,000 watts. So this is the answer. The problem did not ask us this, but we can see what percentage of power is lost to the wire's resistance. Let's see, the power consumed by the wires divided by the power in the total circuit. And this divided by that is going to give us about 5.4%. So 5.4% of the energy will get lost to, or 5.4% of the power will be lost to the wires because the wires have resistance. This is the power that's being lost or wasted because this only heats up the wires, doesn't do anything else. The reason why the wires have so much resistance is because the resistance of a wire is ρ times L over A. We can use good wires like copper or aluminum so the resistivity is low, but there is a limit on how thick we can make the wires. Too thick wires cost more because more material is needed and they are also too heavy to hand properly, so A cannot be big. And to deliver electricity over long distance, we need miles and miles long of wires. That's why the resistance of those wires are not negligible. This also tells us why power companies have to use high voltages to transmit electricity, if the amount of power to be transmitted is the same. The higher the voltage, the less the current we have in the circuit. And when we look for the power consumed by the wires, it is I squared R. So the lower the current in the circuit, the less the power being consumed by the wires. Because we cannot really reduce the resistance in the wires. We can also look at this quantitatively. If the voltage we use is doubled, then the current will become halved. That means the power wasted by the wires will become 1/4. That's why it's worth making the voltage high for power transmission.